Hi guys, welcome back to CVRROCKET, and today in this video we are going to learn about recurrent neural network, RNN in short, forward propagation a little bit, more about backward propagation because the learning happens there itself, how the training goes on, and which will be obviously used for testing. So we're going to, from scratch, we are going to learn how this recurrent neural network is built, how the forward propagation happens in a little bit, and then backward propagation little in depth. So as you can see, this is the structure. Basically RNN we use for time series like data or the problem which we are going to solve, which happens to be a sequence based, sequence to sequence learning. Those kind of problems, recurrent neural network should be the solution you should get in your mind. Obviously LSTMs, GRUs, so these are the advanced versions or the flaws in RNN. They take as advantage, and those problems they solve, like LSTMs and GRUs solve the problems which RNN happens to have. So those problems has been solved by LSTMs and GRUs. So anyway, the starting point for this time series generation, sequence to sequence modeling begins with RNN. So you should be having the thorough or basic idea of RNN so that LSTM GRUs you can grasp it more easily and clearly. So in time sequence to sequence learning, so for those problems you need to have like RNN should be like a little strike in your mind, whether RNN we can use or not. So as you can see, this is the input actually. Example is like anything, any action for present action is dependent on present input and previous output or previous information. So information travels, like propagates from one time to another. If that information is previous information used for current information, current situation, then we can tackle, or we can say that problem as sequence to sequence. So as you can see, this is times actually. You can take this as time 0, timestamp. This is time 1. This is time t. So at time 0, time 1, time t. You can categorize like that. For time 0, we are giving input as x1. So these are the inputs. It can be numeric, it will be class based or anything. But again, in machine learning, data science, basically in computer science, we like to give a numeric form because it will be easy for the computer, and computation also can be easier and easier for computer. That's why. So we are feeding x1 input here, and here I will have some functions also which I will tell you now. So this input has been passed over here. Actually this is the 0th h0. This function is actually we can just give 0 padded because this is initially we are initializing something, so we can give 0 padded vector. So h1 here, as you can see, ht is tan h of uxt. So u is a weight which we are giving, and if you a little bit know about data science or deep learning, machine learning weights play a major role, because of weights only we able to learn much. The network is able to learn very much. So we are adding this weight to input, so uxt, and we are adding that with wht minus 1. so w is over here. This is a weight which carries the previous information. Initially h0 is 0 padded because we are just starting the network now. So w into h0 coupled with this activation function. These are the activation functions which you might know. So with that we can get an output desired, like for two class in output 0 1 we can use sigmoid, something like that. And if you want a classified output softmax, so various functions are there for activation functions. So based on that we will use tan h, softmax, sigmoid, like that. So here we are using tan h activation function, so that fetches you h1 here, and that h1 is going to use for yt. So that h1 is going over here coupled with the v weight, so v into ht, and that is passed through softmax so that we can get y1. So this is the output actually. This is output for this thing, just for this flow. As you can see here, we have two flows. One flow is like this, one flow is like this. I will explain what that in detail means. Now you just simply think this as a simple machine learning problem where we just passing input, we are using some weights here, two weights for suppose, and then we are using activation function to get an output. So this is one flow. This seems to be like small weather prediction, like that problem in deep learning which we will use fully connected layer, dense layers, and we'll pass and we'll get output based on our results, positive, negative, like that, two class output. You can think something like that, this flow.